section 5.5 integer exponents. First, let us recall natural number exponents. So, b to the first power is just b for any base b. B to the n plus 1 is equal to b times b to the n for any natural number n. B is called the base, and n is called the exponent. Okay, so let me do integer exponents. So let me suppose that b is not 0. Then I'll define b to the 0 to equal 1. And I'll define b to the negative n to equal 1 over b to the n. Again, where, like above, n is a natural number. Okay. So let me give you some rules for exponents. So again, this is just a review from before. So let m and n be integers. B to the power m times b to the power n is just b to the power m plus n. Now, when I write this, I'm assuming that both sides of my equation exist. And so, if it happens to be the case that one side of the equation doesn't exist, then the other side of the equation doesn't exist. And so, what I mean by that is, suppose b were 0, and I had a negative exponent, then then this is still a true statement. I just, if it doesn't exist, then just assume that that this is a true statement whenever it exists, and if it doesn't exist, then well, it doesn't exist. Okay, so let me do problem number 2, property number 2. B to the m divided by b to the n. Well, this is just equal to b to the m minus n. So in the first property, if I had the same base and I'm multiplying, then I add exponents. Here, if I have the same base and I'm dividing, then I subtract exponents. In general, actually, we like to have these simplified so that we have positive exponents. And so this is really just b to the m minus n if m is greater than n, 1 if m is equal to n. Again, I'm assuming here that this exists. So meaning like I don't have 0 to some power. So this is it's equal to 1 except when b is 0. Then you'll have like that would be 0 to the 0. And it's equal to 1 over b to the n minus m if m is less than n. Property 3. B to the power m to the power n. So if you have a base, you raise it to an exponent, and then you raise that to another exponent. Then you just multiply exponents. And so this is just b to the power m times n. Next. B to the 0 is 1. This is so long as b is not 0. Next. B to the 1 is b. Next. AB to the m is equal to a to the m, b to the m. Next, a divided by b to the m is a to the m over b to the m. Again, I'm assuming I'm not dividing by 0. So maybe I'll just sort of, well, again, assume that, that these exist. 8 b to the minus n equals 1 over b to the n. And again, you're assuming that this exists. So if n is a integer, then I'm assuming here that b is not 0. And maybe if I'm assuming m is an integer, then is a natural number. Do I assume? Oh, I assumed is integer. So 9 0 to the power m is 0 so long as m is not equal to 0. So I'm not going to define 0 to the 0. Let me do some examples. Let's say on page 205, let me do problem number 2. 1 over 3 to the power negative 3. So in exercises 1 through 16, evaluate the numerical expression. Okay, so since I have a negative exponent says to take the reciprocal. So let's take the reciprocal. The reciprocal of 1/3 is 3. And 3 to the 3rd is 27. That is your answer. Let me do problem number 4. 2/3 to negative 3. Again, I have a negative exponent, so let's take the reciprocal. Reciprocal of 2/3 is 3/2. Change the exponent from negative to positive, so change its sign. And now let's use the properties of exponents to simplify this. So let's raise both the numerator and denominator to the power 3. Well, 3 cubed is 27, 2 cubed is 8, and so my answer is 27 over 8. Let me do problem number 8. Negative 3 over 4 to the negative 2. So I have a negative exponent, so let's take the reciprocal. The reciprocal of negative 3 over 4 is 4 over negative 3. Change the exponent from negative to positive. And so let's square each of these. And so this is 4 squared over negative 3 squared. 4 squared is 16. Negative 3 squared is 9. And so my answer is 16 over 9. Let me do problem number 10. 4 to the negative 3. And so I have a negative exponent. So let's take the reciprocal. The reciprocal of 4 is 1 over 4. So this is 1 over 4 cubed. Well, 4 cubed is 64. So this is the same as 1 over 64. Let me do an example. And so, suppose I want to simplify negative 2 thirds to the negative 3. I have a negative exponent, so I'll take the reciprocal, which is negative 3 halves cubed. A negative number cubed is negative. 3 cubed is 27. 2 cubed is 8. And so my answer is a negative 27 over 8. Let me do another example. Negative 2 thirds to the negative 4. I have a negative exponent, so let's take the reciprocal. The reciprocal of negative 2 thirds is negative 3 halves. Change the exponent, the sign of the exponent, from negative to positive. A negative number raised to a even power, 4, will be positive. 3 to the fourth, 3, 9, 27, 81. 2 to the fourth, 2, 4, 8, 16. So my answer is 81 over 16. Let me do problem number 12. One over 3 to the negative 2. And so I have a negative exponent. Let me bring this up from the denominator up to the numerator. And so there was just 3 and negative 2 in the denominator. So there's just a 1 remaining in the denominator. I don't need to write that. 3 squared is 9. And so 1 over 3 to the negative 2 is just equal to 9. Let me do problem number 16. 2 to the negative 2. over 4 to negative 2. Again, I have negative exponents, so I'll bring the 4 up to the numerator, the 2 down to the denominator. And so I get 4 squared over 2 squared, which is just equal to 4 squared is 16, 2 squared is 4, 16 divided by 4 is 4. Okay. Let me do problem number 18. In exercises 17 through 54, write the expression with positive exponents. All variables are non-zero. So we're going to assume that basically everything exists. So we don't have to worry about existence or anything. And whenever we want to simplify, we always want to write our final answer with positive exponents. And so I have here y to the power 2 to the power 5. And so this is just a base to a power to a power. You just you keep the base and you multiply exponents. 2 times minus 5 is a negative 10. And so I have a negative exponent, so I'll take the reciprocal. And so this is just 1 over y to the power 10. And that is my final answer. Let me do problem number 24. Z to the negative 2, z to the 5 over z cubed squared. Well, if I look at the numerator, I'm multiplying, so I have the same base, z. I'll add exponents. Negative 2 plus 5 is 3. I have in the denominator a base to a power, so I'll just multiply exponents. 3 times 2 is 6. And now I see that I have the same base, z. 6 is bigger than 3, therefore z will be in the denominator. And then I'll just subtract exponents. 6 minus 3 is 3. Since z is in the denominator, I need a 1 in the numerator. So this is 1 over z cubed. Let me do problem number 28. Two x cubed y to the negative 4, 3 x to the 4, y to the 4. First, let me bring the quantity with a negative exponent, interchange it between numerator and denominator. Well, there's only one, so I'll keep the 2x cubed in the numerator, the 3x to the 4th, y to the 4th in the denominator, and I'll bring the y to the 4 from the numerator to the denominator. And when I bring it from the numerator to the denominator, I'll change this negative 4 to a positive 4. And now let's simplify. Well, 2 and 3 I can't do anything with. I have here an x cubed and an x to the 4th. So we have the same base, x. 4 is bigger than 3, so x will be in the denominator. Let me make this a little nicer. Next, 4 minus 3 is 1, so this is just x to the 1st. I have y's in the denominator, and so I'm just multiplying. So I have the same base, y, and I add exponents. 4 plus 4 is 8. And that is your final answer. Let me do problem number 36. 36. 5. A cube, b square, 6a to the negative 2, 6 b to the 6 quantity squared. Okay, so let's simplify this. So let's square everything. So this is 5 squared, a cubed squared, b squared squared, 6 squared, a to the negative 2 squared, b to the 6 squared. 5 squared is 25. I have a base to a power, so I just multiply exponents. 3 times 2 is 6. I have a base to a power, so I just multiply exponents. 2 times 2 is 4. 6 times 6 squared, 6 times 6 is 36. I have a base to a power, so I just multiply exponents. Negative 2 times 2 is negative 4. I have a base to a power, so I multiply exponents. 6 times 2 is 12. Okay. I have a negative exponent, so I'll bring this from the denominator, up to the numerator. And so I have 25. I'll bring up the a to the 4th. I keep a to the 6th, b to the 4th. In the numerator, I keep 36 and b to the 12th in the denominator. And so this is equal to, well, I can't really do anything with the 25 or 36. I have a to the 4th times a to the 6th. They're both in the numerator. I'm multiplying, so I keep the base and I add exponents. 4 plus 6 is 10. I have the same base b. Since 12 is bigger than 4, b will be in the denominator. And I'll subtract the exponents. 12 minus 4 is 8. And that is my answer. Let me do problem number 46. Two, a to the negative 2, a to the 6, b to the negative 1. Okay, so let's multiply. So this is 2. I have the same base a. I'm multiplying, so I add exponents. Negative 2 plus 6 is a positive 4, b to negative 1. And so I have a negative exponent, so I'll bring this from the numerator down to the denominator. And so I have here 2a to the 4, and I'll bring the base, the b, from the numerator to the denominator. And so that's b to the 1st. So my answer is 2a to the 4th over b. Let me do problem number 54. Three to the negative 4, a squared, b to the negative 4, 3 to the negative 5, a to the 4, b to the negative 2. So I have a negative exponent. I'll bring this to the denominator, bring that guy to the denominator. I have a negative exponent, so I'll bring this to the numerator, and I'll bring that one to the numerator. Okay, so This is equal to, well, this is no longer there, but I have an a squared in the numerator. Okay. I'm bringing the 3 to the negative 3. I'm sorry, that's 3 to the negative 5. I'm bringing 3 to the negative 5 up to the numerator. I'm bringing the b to the power 2 up to the numerator. I'm bringing, well, I noticed that I brought the 3 to the negative 5 and the b to the negative 2 to the numerator. So the only thing remaining in the denominator is the a to the 4th. I bring the 3 to negative 4 to the denominator, so that's 3 to the 4th. And I bring the b to the negative 4, b to the 4th, to the denominator. So let's simplify this. So I have the same base, 3, between the numerator and denominator. 5 is bigger than 4, so I'll keep 3 in the numerator. 5 minus 4 is 1, so this is just 3 to the 1st. Next, I have a squared and a to the 4th, so a will be in the denominator. Since 4 is bigger than 2, 4 minus 2 is 2. I have b to the squared and a b to the 4th. And so b to the, well, 4 is bigger than 2, so b will be in the denominator. And again, 4 minus 2 is 2. And so this is 3 over a squared b squared. Let me do problem number 60. In exercises 55 through 60, evaluate the expression for x equal 2 and y equal negative 3. And so I have here negative 2, y, x to the negative 2 squared. So first let me simplify this. And so this is the same as negative 2 squared, y squared, x to the negative 2 squared. Negative 2 squared is just 4. Y squared, well, that's y squared. X to the negative 2 squared as well. Negative 2 times 2 is a negative 4. Again, I have a negative exponent, so I'll bring this from the numerator to the denominator. And so I have 4y squared over x to the 4th. And so I want to evaluate this. So notice that I should simplify first before I evaluate. So let's evaluate this. When x equal 2 and y equal negative 3. Let's do that. And so I'll plug in for x 2 and for y negative 3. Negative 3 squared is 9. 2 to the 4th is 16. 16 divided by 4 is 4. And so my final answer is 9 over 4. Let me do problem number 70. In exercises 61 through 70, simplify the numerical expression. 4 to the negative 2 plus 2 to the negative 2. And so I have a negative exponent, so let me take the reciprocal. So this is 1 over 4 squared. I have a negative exponent, so let me take the reciprocal. 1 over 2 squared. 4 4 squared is 16. 2 squared is 4. In order to add fractions, I need the least common denominator, which in this case is 16. 16 divided by 16 is 1. Let's multiply and divide by 1. 16 divided by 4 is 4. So let me multiply and divide by 4. And so I get 1 over 16 plus 4 over 16. I have the same base. I have the same exponent, sorry. I have the same denominator, 16. Let's add numerators. 1 plus 4 is 5. And so I get 5 over 16. Let me do problem number 72. In exercises 71 through 74, simplify the expression and write the answer in terms of positive exponents. So again, even if we don't tell you, you should always write your answer with positive exponents. That is always the basic assumption. 3, x to the negative 3, y to the negative 2 squared. So let's raise each of these to the power 2 and simplify. And so 3 squared is 9. X to the negative 3 to the power 2. Well, by laws of exponents, you multiply exponents. Negative 3 times 2 is negative 6. Again, y to the negative 2 squared. Again, you multiply exponents. Negative 2 times 2 is negative 4. Well, we have negative exponents, so bring each of these to the denominator. And so this is just equal to 9 over x to the 6, y to the 4. And that is your answer. Let me do problem number 74. Negative x to the negative 2, negative x squared y to the negative 1 squared. So let's raise each of these to the power 2. So this is negative 1 squared, x squared squared, y to the negative 1 squared. Negative 1 squared is 1. X squared squared, well, 2 times 2 is 4. Y to the negative 1 squared, negative 1 times 2 is negative 2. I have a negative exponent, so let me bring this from the numerator to the denominator. And so I have here x to the 4th over y squared. And that is my answer. Let me do problem number 78. In exercises 75 through 80, simplify the expression and write the answer in terms of positive exponents. Y over x squared to the negative 3 x over y squared. So this is equal to, well, let's raise everything to the power negative 3. So this is y to the negative 3 over x squared to the negative 3 times x over y squared. And so this is equal to y to the negative 3x over, again, I have a base to a power, so let's multiply exponents. 2 times negative 3 is negative 6 y squared. I have a negative exponent, so let's move this from the numerator to the denominator. Negative exponent, so let's move this from the denominator to the numerator. And so I get x to the 6 times x over y cubed times y squared. I have a same base. I'm multiplying, therefore I add exponents. And so 6 plus 1 is 7. I have the same base, y. And so I add exponents. 3 plus 2 is 5. And that is your answer. Okay, so let's recall the following. And so this is just order of operations. Well, it's an order of operations notation. So if I had something like 2 to the power 2 to the power 2 to the power 2, etc., the question is, well, what would that equal? Well, it turns out that 2 to the power 2 to, I don't know, let's say that. Whenever you evaluate these towers of exponents, well, you start at the top, and so this is the same as 2 squared, and then you raise that to the power 2. How many of these? 2, 4, 6, 3. Raise that to the power 2. Raise that to the power 2. Raise that to the power 2. And so, let's see, this 2, 4, 6, 2, 4, 6, yeah. And so, this is how you would evaluate any sort of tower that doesn't have, of exponent, where you haven't put down already what the parentheses are. And so, the parentheses go from top to bottom. And so, suppose you had problem number 80. Y cubed squared. So this is just y cubed squared. So you evaluate the 3 squared, which is 9. So this is y to 9. And that is your answer. Okay. So that's it.